The next example is about expected value analysis. So far we have seen how we can calculate total cost for different alternatives, but there are some uncertainties, for example, in the demand, and we do not know what will be the demand in the future. What organizations do is to come up with some estimates for the demand in the future, and then they can determine some demand levels with some probabilities associated with these demand levels. And what we do in this analysis, in this expected value analysis, is to take into account these uncertainties in the demand. So we have capacity cost structure for different alternatives, and then we have expected demand, or we have multiple scenarios for the demand. Let's assume that we have I scenarios for demand in future, and then there is a probability associated with each of these scenarios. Then for each capacity alternative, we can calculate the expected value, as you can see in this formula. So expected value would be the summation over I, or over different scenarios for demand, of the expression that you can see here. This is the probability of demand level I multiplied by the financial results or outcomes at demand level I. Let's see the example. This is an extension of the previous example. So we have here three different alternatives: common carrier, a contractual agreement with a company, and then leasing some trucks. And for each of these alternatives we had fixed cost and variable cost. This is what we saw in the previous example. And then we can see that there are three demand scenarios: low demand scenario, medium demand scenario, and high demand scenario. For the low, we have 30 million per year number of shipments, then for the medium 50 million shipments, and for high 80 million shipments. And there is a probability associated with each of these scenarios. For example, for the low demand scenario, the probability is 25%, or in other words 0.25. And what we want to do is to answer this question: what is the expected cost for each alternative? Here we will show the costs calculated for the first alternative, and then you can do the same to calculate the cost for other alternatives. You can also see some comments in the slides in which I have explained the calculations. Okay. For the common carrier, we need to calculate the cost for each demand scenario. So as you can see, it is the cost for the low demand scenario, cost for medium demand scenario, and then cost for high demand scenario, denoted by C low, C medium, and C high. Let's see how C low is calculated. For the first alternative, the fixed cost is equal to 0. So we have the fixed cost plus variable cost, which is 750 in this case, multiplied by 30, which is the number of shipments. Of course, it is in millions, so we need to be careful how we are interpreting the numbers that we get. So it is 750 multiplied by 30. So we will get 22,500 as the total cost if demand become equal to 30 million. Then for the other scenario, which is the medium demand scenario, again we can do the calculation. So we have 0 as our fixed cost. You can also see it here in this table. Then we have 750, which is the variable cost. You can see it here. And then 50, which is the medium demand scenario. And then we can calculate the total cost. In a similar way, we can calculate the cost for the high demand scenario. Having these numbers, having these costs, which are the financial outcomes or financial results of each demand scenario, we can calculate the expected total cost. Here, the expected value is the expected total cost because we are working with the costs. It could be the expected revenue, expected profit, or whatever, based on the problem that you are dealing with. So, for this alternative, which is the first alternative, the expected value or expected cost is equal to the cost for the first demand scenario, which is 22,500, that you can see here, multiplied by its probability of that demand scenario, which is 25%. Here you can see it in the table. Plus the cost associated with the second demand scenario multiplied by its probability, and it's the same for the cost of the third scenario and its probability, which will give us a total cost of total expected cost of 37,125. For the second capacity alternative, if we do the same calculations or similar calculations, we'll get a total expected cost less than 20,000, and the expected cost would be about 23,500 for the last alternative, which is leasing. And based on this expected cost or expected value calculations, we can see that the expected cost for the second alternative would be the lowest.